So hello everybody and welcome to our Azure Back to School video, which is entitled AIoT, Edge Video Analytics and Azure. You're joined by me, John Lunn, and we've got Chris. How you doing, Chris?
Hiya, John. I'm very well, thanks, mate. Yourself?
Yeah, doing good, thanks, mate. This is going to be an interesting session, isn't it? I think we've had a decent amount of time trying to work it out. So yeah, how are you feeling about this, Chris?
Yeah, I'm really looking forward to it, John, and getting to learn more about IoT as well as AI and the integration of both technologies.
Yeah, absolutely. I mean, on that note, then, we'll just head over to our desktop and let's get stuck in. Should we kick off with a few quick introductions then, Chris, before we get into the nitty-gritty of what we're going to talk about today?
Yeah, John. So I'm Christopher Wright, or well, Chris. You can catch me on LinkedIn or Twitter, as you can see from the slide deck. Currently an Azure SME for HTG. I've been in that role now for a couple of months. Yeah, and I'm willing to, something that I really want to look into it is IoT. Got a very keen interest. We're really looking forward to learning more about the AI, and I know you've got quite a bit of experience in, John.
Well, I wouldn't say that. I've dabbled, I think is probably the best way to put it. So yeah, I mean, from my point of view, for everybody that's watching, thanks for tuning in, and big shout out to Dwayne for setting up the back to school event as well, of course. So yeah, I'm John Lunn. I'm a technical architect working for BT Enterprise in the UK, and yeah, part of this series is really, I think, the way that it's set up, the back to school, is to take somebody that may not have much experience of a particular topic area, which, to be honest, is probably me, but maybe then somebody that has got some experience, which I think I'm trying to act in that capacity at the moment, and take somebody else through it. So that's the role of me and Chris today. The topic area, AIoT, Edge Video Analytics, and Azure. So I mean, without further ado, Chris, should we just kind of kick straight into the agenda and have a little look about the areas that we're going to look at? I mean, shall I quickly rattle through these then, and you can obviously pick up any questions you've got as we go through this. We'll address, because clearly that's the point of the video. So we'll start off with
John. That sounds fantastic.
No, cool. Well, I mean, we'll start off with that basic, like, what is AIoT? We'll have a little bit of a think around that, and some scene setting to understand, why did I get involved with looking at this to begin with? And, Chris, from your point of view, why might you want to start looking at it as well? Obviously, we'll look at what the solution is we're going to look at. So this video is about looking at that end-to-end solution of a video analytics solution, literally from developing the solution that sits on an edge device, right the way through to taking that video data and inferencing it and sending messages, right the way through to doing something with that information that you're getting out of that. So we're going to look at what that solution might look like, or what the solution is, the demo that we're going to look at today. But along the way, we're going to dip into each of those areas. So we've got things like the NVIDIA Jetson Nano, the device we're going to use. We've got the DeepStream SDK, which is from NVIDIA as well. And then we're going to look at some of the Microsoft products like Custom Vision AI, like Stream Analytics and filtering telemetry, using that service. And then, using time series insights and Power BI for visualizing some of that data. Does that sound good with you, Chris? Any questions at this point?
Yeah, no, that sounds fantastic, John. Yeah, really keen to get stuck in and learn more.
Cool. Right. So what is AIoT? So I've taken this straight off the internet, actually. So the artificial intelligence of things, AIoT, it's really the combination of that artificial intelligence thing that we're all hearing a lot more of today in today's world, and combining it with that IoT, kind of that maker IoT, small device, embedded device technology, and kind of doing things, doing clever things with AIoT that you probably have seen over the last few years, but it's one thing seeing it, and the point of this kind of demo that we're going to run through is to understand how we as IT pros, as maybe a little bit of dev expertise, how we can get involved with this. So it's about the emergence of this AI and IoT kind of services, and I'll read that out. So it's to achieve more efficient IoT operations, improve human-machine interactions, and enhance data management and analytics. Chris, did that make any sense to you?
Yeah, in short, yes. Yeah, it's obviously the AI that we all know from back when I was younger, AI was a thing of the future, really. And I think now we're literally living through an age of AI, with a lot of computer learning. And then it's also the integration with devices out there, and that can improve things for people.
Absolutely. And to be honest, Chris, this is why, I mean, just flicking over to the next slide to kind of set the scene as to, why did I get involved with this? So, we both work in tech. Arguably, we're both self-professed non-developers. Am I speaking for you there, Chris? We're probably of the similar ilk. We're very much in the ops side of the world. But with time and things that are moving on so rapidly with AI and machine learning and IoT, it was a case of, how do we get involved? Certainly for me, the spark for me was playing about with Raspberry Pis, doing some clever things, getting some maker kit and components on a breadboard and trying to make things and maybe delve into the coding to a certain extent, but do something clever that kind of does something of benefit, even if it's just for learning purposes. And this is what kind of inspired me into this world. So back last year, I saw that NVIDIA, I don't know about you, Chris, but I had a couple of Raspberry Pis kicking around the office space, and I was dabbling around, playing around with things. And then I saw NVIDIA had kind of released this Jetson Nano kit. So I thought, I'll take a look at that. And, fundamentally, we'll get into the detail in a little bit more detail of what the Jetson Nano device actually is. But to set the scene, I bought one of these devices and I thought, I'm going to do something. I'm going to do something great and we're going to have fun. So, I started fire up the Visual Studio Code. What can I do? What can I find from a resource point of view? So I hooked into this, and I'll talk about the Paul DiCarlo bit in a second, but I hooked into this fantastic set of resources that kind of helped learn right the way through from, start to finish, an end-to-end solution, which kind of used cameras, as you can see there, that particular Wi-Fi enabled camera that I've got sat in my studio here. That little box just below is the Jetson Nano sat on my desk just down here. And of course, that's what I'm looking at. So that's my setup. I was taking pictures, as I normally do, fire them out across Twitter, having a bit of fun. But basically, it was about that inspiration. It's about getting that spark for wanting to learn about this technology. So as I worked through this series of modules, like I say, I found... I hooked in with Paul DiCarlo, who's one of the cloud developer advocates over at Microsoft, and he's done some fantastic work, and he still is doing some fantastic work in other areas at the moment, things like the Percept Dev Kit and stuff like that. But back last year, I stumbled across the fact that Paul was running the ability to kind of learn a bit more about the Jetson Nano. Why the Jetson Nano? Get into it. So I got involved with some of the NVIDIA Deep Learning Institute learning courses, effectively, which basically took you through how to set up a Jetson Nano, a bit like Raspberry Pi, how to get that set up and the kind of things that you can then do with it. And one of the cool things... Yeah, go on.
Sorry to interrupt, just a question there. Why would somebody pick one of these? Obviously mentioned Raspberry Pis and you've dabbled with them in the past. What is there a benefit to using a Jetson Nano, or is it just like, you go out and buy a car, but you can buy different choices? Is there a reason specifically for this that you've gone for the Jetson Nano?
Well, yeah, I mean, it's a very, apt question, to be honest, Chris. And I think the answer is, to say it in layman's terms, the Jetson Nano is like a Raspberry Pi on steroids. It's got the oomph. It's got a huge GPU, and we'll touch on the specs of that in a second. Now we'll take a look at the oomph. But yeah, you're right. Some things that we need to do, especially with like video analytics, it's quite processor intensive kind of things that we need to do. And we know with Raspberry Pi, you've got a single core or dual core chip in a Raspberry Pi. When it comes to doing kind of that real-time inference, that real-time detection across a series of real-time motion pictures, you kind of need to run things in parallel. And I think the 2 gig version of this, which we'll dip into in a sec, has got like 128 GPU processors on it. So we can do a lot of parallel processing, which comes in very handy when we want to do some work. Does that make sense, Chris?
Yeah, no, definitely. Yeah, I can see how obviously it's analysing video now, and the more GPU that you've got, it can process that a little bit better than a Raspberry Pi.
Yeah, and definitely there are models that you can use on Raspberry Pis and mobile phones that will do a reasonable enough job. But I think that the point of the Edge device, and we'll get to that in a second, is the how much number crunching, how much CPU are you going to actually need to process those images? And basically, the main difference with the Jetson Nano is the fact that it's, like I say, that it's got that oomph with the GPU, and that kind of, maybe that tells in. So like I say, when I was going through this back last year, Paul DiCarlo actually got wind of this, only because I was being blasé across Twitter and picked up on some of the imagery that I was putting out there. But he called me out in GTC, which was pretty cool, and I was flabbergasted that somebody like Paul would give me the time of day, which it just goes to show, doing these kind of videos and helping others get involved in this tech is a pretty fun thing. I've had nothing but fun working with this and learning it as I've gone. So really keen, and thankful for you for kind of making this video with me, Chris, because it's, hopefully you get the bug and you go running off and spending copious amounts of money on kit that you probably don't need.
Well, I know where to send the wife when she's not happy with me.
Yeah, sorry. Right, should we kick on then? So that's setting the scene. Hopefully that's kind of helped people understand why are we making this video. And I mean, at this stage, we're hopefully going to be around about the hour mark for this video. So strap in and let's make a start then. So solution overview. What is it that we're looking at? Okay, so chip in now, Chris, at any opportunity that you like. But basically, within Azure, when it comes to doing anything with IoT, and in this particular example, when we're looking at AIoT, so doing some object detection across real-time video, there's a number of components that we can use across Azure and, IoT edge devices. And basically, the whole point of this slide is to kind of pick out the objects that we're going to be looking at during this video. So the first thing we're going to look at is that IoT edge device. We'll dig in a little bit as to what is an IoT edge device. In this case, what is the Jetson Nano, and like you said, why have we chosen it? We're going to look at the SDKs that we can use to kind of send messages from the IoT edge device up to something central like the IoT hub. So the IoT hub is very much the core to the messaging, the communications flow. So it can do both, a two-way flow. So you can send messages to the IoT hub in very much like that topic subscriber type field. So you can send messages that then a subscriber can pull the messages from. But equally, you can send messages from IoT hub back down to your devices if you so wish. And you can get the IoT hub to do things like, over-the-air updates to your devices, or send specific commands to trigger functions or methods that you may have in your devices. So from there, from the IoT hub, we're going to move on to looking at using stream analytics. So as this is an IoT edge device, we're obviously going to be doing some number crunching with analyzing video. We don't want that stream. We'll dig into and we'll show that stream of data, that the IoT edge device will generate. And so have you come across stream analytics before, Chris? Have you done anything with stream analytics?
Funny enough, I was actually looking at a few bits in work last week around stream analytics, but I've not sort of delved that deep into it.
Yeah,
it was more of an overview to see if it would work for something that we were looking at doing.
Yeah, and you know what? To be honest, that was very much similar case for me. I understood at a relatively high level what stream analytics was and what was for, and running through this kind of series of exercises kind of made it real for me, and that's why I'm quite keen to show off the back of that. So we'll dig into stream analytics a little bit later on. We'll also, so once we've done stream analytics, we've looked at IoT Hub, we've looked at what stream analytics is there and is doing for us. We'll touch upon the time series insights features and functionality, and it's about taking that time series data and doing some visualization with it. So we'll jump into the portal and we'll have a little look around that, just to give you a little bit of a flavor of the kind of things that you can do with TSI, that time series insights. And then also from a visualization point of view, we're going to look at Power BI, because Power BI is, arguably the de facto reporting, visualization, dashboard utilization piece of technology that Microsoft has at the moment. So why not use it? Let's see what we can use that for in this solution. And last but not least, we will also be making use of storage, whether or not it's kind of an optional thing that we're going to look into just to kind of give a flavor of how we can use things on the IoT edge devices. So we'll see how far we get and how time works out for us. But does that make sense, Chris? Any questions there? We're going to go through those key areas. You'll see there's lots of other things we could choose from and feed into our IoT solution, but we're not. We're kind of limiting it to those things. Yeah.
Yeah, no, definitely. You know, and IoT, from my understanding, the whole of it, it's integrating all devices, sensors, and you can see even the back end. There's so many services that are integrating, you know, to pull everything together into a complete solution.
No, you're right, and I think sometimes it's great to have kind of technical deep dives on those individual components, and don't get me wrong, they're absolutely necessary to get a really good, rich understanding of those areas. But I think sometimes, I don't know about you, Chris, but I'll watch technical presentations and it's great that you understand how to do something with a particular feature set, but sometimes it's about the context of when might you use that particular feature set. And I think what I'm excited about this kind of presentation is that hopefully it triggers that, okay, I can start to see now how I can glue some of these components together, like you say, to make that kind of end-to-end scenario. So first off then, a little bit of blurb. I'll try not to ramble too much, and I'll try and keep this as layman terms as possible. So, in terms of what is IoT Edge? So, fundamentally, we've got a couple of different mechanisms that we can hook devices up to the cloud. In terms of edge devices, or IoT devices. Sorry, edge devices, a very specific use case. But fundamentally, the IoT Edge device is a mini computer like the Jetson Nano. It could be your PC, it could be a Windows PC, a Linux server, it could be a huge, filled up with RAM and CPU and storage. It could be a huge supercomputer. It's just a computer. In our case today, we're using a relatively small, low-profile PC called the Jetson Nano. What that edge device does is it allows other sensors. So if I click on my little red laser pen and circle, so in this diagram we've got robot arms, and we'll see in a second we've got the ability to hook up any kind of sensor or bit of kit to basically communicate and send messages to this IoT Edge runtime. And what that IoT Edge runtime is, effectively, you could probably think of it as a very pseudo Kubernetes orchestrator type runtime. It's a mini container, or it's a container that is sat on that computer that is basically orchestrating other containers that sit on that IoT Edge device. So, in other words, you've got a bunch of modules, is what we call them. So maybe it's telemetry, maybe it's some insights module, maybe it's some other business logic that we've developed on there. We'll dig into showing what modules we've got, but they're effectively an IoT Edge device is a little computer, or it could be a big computer. It's a little computer in our case, running containers. Does that make sense, Chris?
Yeah, no, it does. It's sort of something that just jumps out at me there. I think you posted several weeks back about now there is a way you can set your phone up as an IoT Edge device.
Yeah. I don't know whether you can set it up as an edge device as such. That's what I say. You've got two ways that you can hook. I might be wrong, but no, I don't think you can set your phone up. So you can download a mobile app that will set your phone up as an IoT device, and I'll show you the difference in a second. The portal, but I'll do another slide and we'll jump into the portal and have a quick look at this. But you're right. There's an app that you can use the sensors because we've all got phones that have basically got gyroscopes, they've got temperature, humidity, they've got all sorts of sensor information on. And to dabble in this, you can absolutely download the app and hook that up to IoT Hub if you want to. And all we're doing is we're using a little computer, this Jetson Nano, that's running a bunch of modules, containers, that talk to each other and send messages up to this thing called IoT Hub. So these modules are doing something, and we'll dig into what that something is in a second, to send those messages up to IoT Hub. So moving on from what is an IoT Edge device, you can see that, to take it a stage further, those modules or those containers, they speak to each other using certain protocols. Now, when it comes to IoT Hub, specifically around what capabilities we have with Azure, we absolutely do have capabilities to use other containers to do kind of message translation from other older or non-supported messaging protocols. So you'll imagine over the years, Chris, there's so many different ways and protocols that devices can communicate with, other devices. You've got Modbus, CAN bus. There's all sorts of different bus technologies. In this case, we've got two main protocols that are used, but if all else fails, we've got HTTPS. Yeah, think of it like that. So to talk about the protocols that we've got in use that we can use to communicate and send messages between those modules and the IoT hub, typically speaking, on something like a cloud gateway device. So when you've got that scenario where you've got maybe lots of cameras or lots of robots or lots of sensors in a single geographical location, you would use probably AMQP to communicate with an edge, a cloud gateway. So that's something like an edge device like the Jetson Nano. So we can take, multiple connections from multiple devices all hitting the same edge device that would then in turn go and communicate up. So yeah, multiple devices all talking AMQP up to the IoT hub effectively via the edge device. Down from that, which generally speaking, when you're not using an edge device, you can use MQTT, and generally it's a slightly lighter weight protocol, not using too much RAM. It's more suited to those embedded microcontroller, those constrained resources type devices, MQTT. And like I say, finally, we can use HTTPS. So we can use HTTPS. And if we look the ports that these messaging protocols use, MQP is default port is 5671, MQTT is 8883. But you'll see we've got the ability to run both of those protocols over WebSockets. So fundamentally, we could talk any of these protocols over 443. Hopefully, you'll understand why 443 is always a good protocol to use when, behind firewalls, because generally most networks will allow outbound internet traffic. So any questions at that point, Chris? Have you followed that so far, or I made a complete hash of explaining that?
No, John, that was I understood all that. Good explanation, really, and a bit of an overview there of the types of ports that someone was using this. As you say, obviously, like 443 should be open many places. It's just nice to have that overall view of everything and how they communicate and what protocols they use.
Yeah, and it's cool. And like I say, there's so much to learn on that level alone. Certainly when, if you were to dig into your own kind of development of microcontrollers and actually putting your own code on there to communicate over MQTT or HTTPS, whatever it is, using those SDKs, clearly there's a lot that you'd probably want to learn and dabble with that we're not going to touch on in this video, because look, this video would be a multi-part series spanning a long time. So we're going to treat this as very high level for the time being. We're just going to accept that there's a number of different protocols and ways that we can communicate between modules. By the way, Chris, your mic's starting to fluctuate in and out again a little bit, so keep an eye on it now as we move forward. Okay, so before we get into that, I'm going to shuffle over to my desktop then. So we talked about, in fact, I'm going to go back. So we talked about what IoT Edge and IoT messaging is all about. So if we flick over to my desktop, which I've got the presentation on, which I didn't want to do, but there we go, put it over there. Right, first thing to call out is this is the GitHub repo that Paul DiCarlo has really done a fantastic job of putting together and covering a lot of these areas that you can follow. Bear in mind, there's about 8.5, 9 hours worth of video content that Paul has made, and we're trying to cram all of that down. It made me laugh, actually, when I spoke to Paul about this. He said he'd taken a year's worth of his knowledge and, trialing and configuration and expertise. He crammed that down into an 8.5 hour video series. And I laughed with him and said, yeah, and I'm trying to cram that down into a 45 to an hour minutes long demonstration. So we've got our work cut out, Chris, but we'll see how far we get now. But this is like I say, the link was at the beginning of the video. You can probably just about see it there. But if you browse over to github.com/toolbox, TOOLBOC, and search for this intelligent video analytics with the NVIDIA Jetson, you will get access to all these superb learnings basically, and access to those videos that you can watch this if you've got the time. But the first thing to call out, then we're going to jump over. We're going to have a look. We've already got my John Jetson. It's already been pre-configured, so I thought we'll skip over the bit of configuring. But basically, it's about jumping onto that device and hooking that up. There's lots of guides out there with how do you hook an IoT Edge device up with IoT Hub in Azure, and you'll see just on your point earlier, Chris, where you talked about IoT Edge versus those IoT devices. IoT devices live in a slightly different area. So these are still devices that are hooked up to IoT Hub within Azure. But the main benefit with IoT Edge, the area here, is that we get access to, once we hook it up, through the portal, we get access to go and deploy some of these modules, these containers, directly onto our IoT Edge device. And just a quick heads up before we dig into the what the Jetson Nano is, and we'll come back to this a little bit. But you can see straight off the bat, we've got 6 modules, 6 containers that are installed on this IoT Edge device, and we're going to dig into these as we go through this series now. So, just a quick heads up on that before we get stuck in. I don't think there's anything I need to cover off now before we go into the first part of what the actual Jetson Nano is. But does that make sense, Chris? So basically, what we've done, we've hooked up our Jetson Nano already, pre-configured it, we've got it communicating with the IoT Hub, and we've pushed down some modules. The reason we've done that is for time saving, and we're going to walk through exactly what those modules are and exactly how we push them down. That all makes sense?
Yeah, that all makes sense. And obviously, I've heard these things, IoT and IoT Edge. Just showing that visually now has given me more of an understanding. Would the right be in saying that sort of an IoT Edge device is something that's doing all the processing, whereas an IoT device, the processing's done away from that?
Yeah, no, absolutely. You can do a certain amount on a microcontroller on an IoT device, but look, it's normally doing something relatively low level, depends on the device, of course, the complexity. But if you're looking at a very small sort of board chip, you're probably running a relatively simple set of code on it, picking up some sensor information, whether it's a door sensor or temperature, humidity, or anything. In our case, where you're going to use cameras, and we're going to feed that data, that camera feed, into an IoT Edge device that's going to do some further processing. So yeah, hopefully you understand then that's why we need that IoT Edge device. It's going to actually do some number crunching and some compute on that. So we'll quickly flick back over to the presentation and flick onto our next stage, and we'll quickly look at the Jetson Nano. We'll talk quickly and briefly around the Jetson Nano just to give it its little bit of airtime. We've already alluded to the fact that it's effectively a Raspberry Pi on steroids, and apologies to anybody from Raspberry Pi watching this, and equally NVIDIA, but I guess that's my way as a layperson to kind of explain it, hopefully without being too disrespectful to either party. But the bottom line is both Raspberry Pi and Jetson Nano devices, they're both awesome devices in their own rights. You asked earlier why the Jetson Nano, why pick one of these devices, and straight off the bat, you can see, the specs there are for the 4 gig version. I bought the 2 gig version, so the entry level from a cost perspective, if anybody wants to get involved with this, I think I paid about £60 UK pounds for the 2 gigabyte version of RAM, and you get kind of like 128 core GPU, lots of parallel processing power. It's a quad core ARM Cortex A57 chip in there. If you are looking at ARM based, so it's that super low powered chip technology that ARM are famous for kind of creating. And you can step that up. I think roughly speaking, you're paying around about the £100 mark for the 4 gig version. Does that make sense, Chris?
Yeah, no, and also you can see how accessible they are. Okay, they're not cheap, as in they're cheap, but they're accessible. To many people out there if they want to have a little dabble in this. They're not sort of overpriced. Where if you going back in my younger days, even a personal computer, you were looking at over £1,000, and now you've effectively got a tiny PC with a lot more processing power than I ever had in in my day.
Yeah.
On a little chipset, really. And the stats there are
it's probably about
really
the size
impressive.
of my hand. Yeah. I mean, it's
yeah.
I mean, it's right, and in terms of what you get with Raspberry Pi, the price you pay for Raspberry Pis is, if you don't buy all the components and the fan and the case and everything, you're looking at about the £35-40 mark, generally speaking, for one of the modern day Raspberry Pis. So this isn't too much more expensive. One word of warning that I learned is that you will want to buy a fan with this. If you're going to do anything in anger, like what we're about to do with the video analytics, you absolutely will want to put a fan on it, because, firsthand, within firing this up, I was shocked and surprised how quickly the heatsink got red hot. And have a guess how I learned that out.
John, I've just got another question there while we're looking at the specification. Obviously, it's named the Jetson Nano. Did they do like a Jetson, just a Jetson, which is a more powerful version, or did they do other varieties of this?
Yeah, good question, actually. And yes, they do. So I think NVIDIA have got, I believe it's called the Xavier series, which, if you like, is probably, I think I got that right, the next step up. But they do have a range of devices dependent on your budget and application. Now, of course, this range, the Jetson, is seen as very much a developer kit for people like me and you to go off, do some learnings, have a play. It's that price point. But absolutely, these devices can be used in production environments without a shadow of a doubt. If you've got the application running on it that's, got all the relevant operational support in place and things like that. But, for the likes of me and you, this is our entry level device in the NVIDIA Jetson as a Jetson Nano range. But yes, they do absolutely, if you browse over to NVIDIA and have a look at the range of developer kits they've got, they do go up in range and obviously price point, so you can get the like I say, the next model up from the one I've got is the 4 gig version. I think you go into the Xavier range then, and so on and so forth. So they do have a range of products, which is a good call out, actually. So if you do go a little bit elaborate with your setup and your learnings, then you could absolutely start running it on one of these larger devices and process more camera. What does that mean? You can process more cameras, you can do more finite inference, and we'll get to some of those valid points, actually, Chris, on that note as we go through this series. So
just before we move on as well, John, obviously I've seen a few people in the community building like Kubernetes clusters on the Raspberry Pis. Can you do a similar thing with the Jetson Nano, so you could stack them and effectively have a cluster of them?
Without a shadow of a doubt, yeah. I mean, at the end of the day, it's a computer. In actual fact, it's got a very similar form factor with this, I believe, an identical pinout to the Raspberry Pi. So you can see in that diagram there, if I go over with my pen, you can see along here we got a whole row of GPIO pinouts, and that is the same layout and same pinouts as the Raspberry Pi. So effectively, I mean, there's no problem with clustering up into, as you see people have done with Raspberry Pis and making a Kubernetes cluster. At the end of the day, it's running a version of Linux on the as an operating system. You can. NVIDIA have got their own flavor of Linux that we will see in a second that we're using on this. But equally, you can spin up any flavor of Linux that you like, and it is just a PC. It is just a PC, a compute device. So yes, you can do that, absolutely. And in fact, it could be an option, certainly a learning option, but inferencing across a clustered set of deep learning SDKs, that would be an interesting concept, wouldn't it?
Yeah, definitely.
Okay, so let's click on then. So first thing we're going to do, so I mentioned at the start of this session that I managed to reach out and speak with Paul DiCarlo. He took me through some of the deep learning modules with NVIDIA. And one of the things we're going to touch on is this thing called the NVIDIA DeepStream SDK. So this is the AI part. This is the bit that we use to develop our applications that can use the artificially intelligent trained object detection models to do all that clever stuff. Now, don't be scared off at this stage, okay? So I appreciate all of that. It very much sounds like it's developer country, developer land, and yes, it is, certainly to a certain extent. And we'll get to the point that makes it sweet for us, lay people, if we say that, deep dive devs, yeah. So the point is, DeepStream SDK has been developed really to use things like, Jetson Nano devices and other NVIDIA products and other, ARM-based products, if you like, to develop applications using this SDK. And typically they are, taking those signals from various sensors like cameras, like robot arms, like, whatever it may be from a sensor point of view, taking that sensor information in to this edge device. So it's labeled as on-prem. I mean, this is my Jetson Nano effectively, and it's doing something with that data on this edge device, this Jetson Nano that we're using, and then taking that up to a cloud service. So in our case, that is our IoT hub. Yeah, that's going to live in Azure. It's sending those messages up to the cloud, and then it's doing something with that cloud data to, maybe raise some alerts, which we're not going to look at to a point in this exercise, but certainly we'll look at some analytics and we'll look at some visualizations, which is where we go into time series insights and Power BI. Does that make sense, Chris? So the SDK is fundamentally a platform, a service development kit to develop applications. Yeah.
Yeah.
So I click over to the next slide quickly because you might have some questions after this, but I'm not going to dig into this in too much detail, but basically, from a development point of view, what this SDK enables us to do is develop applications either using C or C++, which is, we'll talk about this application we're going to use now in a second, or you can kind of use Python-based applications as well. And you can see we've got various layers of, the DeepStream SDK talks to CUDA-X, which is that I won't go into this in too much detail, and I'll try and skip over this, but mainly because I'm no expert, okay, and I'm going to come right out and say that. But when you look at CUDA and TensorRT and the inference servers, it's about the ability to take a machine learned model of lots of different types and hook that into the actual underlying compute platform. So actually being able to efficiently use a machine learning model against the chipset and the GPU architecture that you've got with your compute device, okay? So it's this layered architecture of, from the SDK, the SDK is very much talk at that CUDA-X level, then straight down onto the hardware level. So in other words, you can be confident that using something like the DeepStream SDK, it is very much being developed for application using these chipsets and these devices, specifically multi-GPU devices. Hardware accelerated devices is the term that tends to get thrown around quite a lot. So does that make sense? And I'm not going to dwell on this too much. This is the developer part, but any questions at that point, Chris?
No, John. No, I'm happy to move on from that bit.
And we can come back to that. And to be honest, this is a great area of further learning, to be honest. And it's certainly an area that, given more time, I'm going to dig into and look into. So if we don't need to worry about the development, how are we going to run an application on the Jetson Nano? Well, thanks for asking, Chris. We're lucky.
You're welcome.
No, absolutely. So we're lucky because with the NVIDIA DeepStream. So NVIDIA, and we'll look at this in a second. If you remember, I had those 6 modules on the IoT Edge device. One of them was called an NVIDIA DeepStream SDK module. And as luck would have it, that is a pre-canned container that contains all this DeepStream SDK, but it also contains sample applications, which is great. So it contains a fully working application that we, as learners and developers / learners, trying out of this stuff, yeah, help me out, Chris.
Yeah, so in essence, really, it's where I was saying how the accessible these devices are, they've also built the software for you to use with it. So from out the box, you don't have to sit there and develop a program effectively. They've given you the tools to get a head start, should we say?
Yeah, no, absolutely, and I think at this point maybe we'll quickly flick over. So what we're seeing here, that's the sample application, and you can see that fundamentally we got the ability to take feeds from cameras, which we're going to get to, and I know we've been going on. We are going to get to. We can pass them through a video decoding thing that then multiplexes that video, stitches video together, that then sends that video multiplexed image through an inference, through a learning model. Yeah, a machine learning object detection model that then you can add things like trackers, so you can detect objects as they move through the field of view. And you could even then stick on things like secondary classifiers. So things like, you've done an inference across an image and you've detected a car. You could then do a second inference that says, right, I've detected a car, right, can you tell me what make, model, and color that car is? Things like that. But this is the sample app. This is the power that we've got. With straight out of the box, we can use a configuration file and dig into that sample app. We'll touch upon some of that config in a sec when we flick over to the desktop. But for now, jump on over to that link. If you want to learn more about it, jump on over to that link and take a look at that. So that's one of the free courses that NVIDIA offer. And there are a couple of free courses, and they're well worth jumping on and having a little look at. So let's jump back over to the desktop a sec, Chris, and let's just take a look at some of this then. So I mentioned earlier on that we've got our Jetson Nano, and straight off the bat, let's just jump in feet first, shall we? Shall we say, right, I'm logged in here to my Jetson Nano. If I clear the screen and I go IoT Edge list. So I want to get a list of all my modules that are running on my IoT Edge. So if I, call out here that we can see I've got my 6 modules there in the background running from an IoT hub point of view in Azure, you can see 1, 2, this has got overlying 3, 4, 5, 6, and hopefully you'll see that the names match. So I'm really just seeing the modules that are currently up and running on my Jetson Nano device. Okay.
Yeah.
Should we quickly jump on over and have a quick look at the Jetson Nano then and see what that's given us?
Yeah, definitely. I think it's what everyone at home's waiting for as well, John.
I think so. 40 minutes in, we got there in a little bit of time. So straight away then, capture card. There we go. So this is my Jetson Nano. And you can see it's picking up 2 cameras. So I'm going to wave at that camera there, which is the camera you saw a picture of. And you'll see it's flickering these bounding boxes around me. And you can see that above me, there's another camera, which is, flickering some boxes around cars and things like that. Now, if I quickly flick my KVM and try and get over to that, I can click on these images. And this is part of the application, remember. This is the sample app that's running. And you can see it's detecting a car. It's got the bounding box. I can come out and I can click on my image in my studio. It's detecting a chair. It's not detected me as a person, but now and again, there we go. It comes on. But that is the application that's currently running. And just take note, actually, if I come back out of that.
That is really, to me, that is really impressive. The fact that you've got this tiny device that's the size of your hands and it can process that much information. It's a bit mind-blowing, really.
It absolutely
how
is.
Much,
yeah,
things have developed over the years, but the power that device has got to actually, scan them images, detect them, even label. Could see on the camera that was labeling it up as a car. It knows what it is. I think that's just.
Absolutely. So let's use this section, the next 5 minutes or so. We'll dig into, right, how is it getting to that point? How did we get that application to that point? So let's hide that view for a second. We'll go back over to the desktop and you'll see that we've got these objects running. We've got these modules running. And the module of interest to us is this NVIDIA DeepStream SDK. So let's dig under the hood quickly and look at the logs. Yeah. So if I use, your typical Docker logs, Docker logs /f NVIDIA. Let's just have a quick look, see if we can have a look at the logs. Straight away, Chris, that's flashing up on our screen now. What do you make of that? So, do you remember those bounding boxes? Yeah. So those bounding boxes that were appearing, I can tell you that they were appearing every fourth frame of the video. And whenever those bounding boxes appear, believe it or not, the module, that NVIDIA DeepStream module, is sending messages, and these are the messages that are being sent. And this is real time, the messages being sent. But where are they being sent to? Where do we think they're being sent to at the minute, Chris?
Well, they're getting sent up to the cloud.
Right.
Did I say?
No, remember, we're dealing with an edge device. Why would we not want to send this up to the cloud? What would be the reason that we might not want to send this up to the cloud?
So effectively, that is compiling it all, is it, into a one-time, so that we're not constantly sending that information up to the cloud. Is that also compiling it on its own, and then we'll connect to the cloud every, I don't know, 30 seconds or something?
Right, almost there. Right, I'll explain it. So this is what's going on. Every fourth frame, we're getting messages sent. So I've just paused that there, just canned out of the log stream. And we can have a look at some of these messages, and we can see that it's capturing things like, okay, from the sensor ID of street, I'm picking up, I got all of these numbers. Now, if I were to tell you that these numbers are actually the coordinates of the bounding box on the screen, yeah? And it's actually picked up a tag of car. So I found a car. I found another car. I found another car. Oh, I found a truck. And as it happened, I don't know if we can flick back over. Yeah, maybe up in the top there, that green box probably recognised as a truck. It's a van, really, isn't it? Let's face it. But it's been recognised. So this is happening every fourth frame. So remember, if we're filming at 30 frames per second, these messages are being analysed and sent every, quite a lot of messages. And you can imagine if we scale this out to more and more cameras, there could be hundreds and hundreds of these messages. They're actually being sent, Chris, to this Edge Hub module that's sat on the edge itself. Yeah. In fact, we'll get to the point in a second where they're actually being sent to this DeepStream Analytics module that we'll get to, and then being sent onto the Edge Hub, which then sends them up to the cloud. But we'll get to that point. But you're along the right track. So why would we want to, send all of those messages? And we can kind of, use Visual Studio. We can jump over to Visual Studio, and we'll see if this works now. But if I start monitoring the built-in endpoint, let's just see if we do actually get anything from the Jetson Nano. So you can see, and we'll get to this point in a second, but we'll see that there's a message that comes up, not as fast as those messages that were just coming up on the screen there. Yeah? So we've got a message there received, and that, look, 42, 57, that's about 15-second difference there, isn't it?
Yeah.
So, and it's, it's count. We've got sensor ID studio object. So it's detecting, it's sending some messages out, and we're monitoring the actual Jetson Nano device as it is, installed in IoT Hub in Azure. But hold that thought, Chris, because every 15 seconds we seem to be getting a message that's sent across. So how did we make that application do what it's doing? So first and foremost, and I'm going to skip through this as quickly as possible for the purposes of time on this video, but if you imagine, we got the ability to either install these modules through IoT Hub, through the Edge devices in Azure, from the marketplace or whatever it may be, or we can develop this JSON formatted, effectively it's a deployment template, it's a deployment manifest that we can use to push to IoT Edge devices. And what this contains is a description of the containers. So if we look at it briefly, we've got this Edge agent. If we scroll down, the system module is Edge agent. We've got a system module of Edge Hub, and they're based on an IoT Edge container registry from Microsoft, version 1.2. So if you're familiar with containers or Docker, in particular, and container registries, what this manifest is doing is grabbing, or it's telling the IoT Edge device to download that container image and store it in its memory and use that image. Yeah. So we've got two system modules. If we scroll down, remember we had 6 in total. So now we've got these custom modules. We got this NVIDIA DeepStream. That was the one that was sending us all those messages. Yeah. And if we look there, the image is coming from the NVIDIA container registry.io, NVIDIA DeepStream. Yeah. So you can see this is that pre-canned container that all we're doing is we're saying our test 5 app, which is the sample app that we've got, we're setting that as an entry point and we're passing it this configuration file. Okay, and we'll dig into why this configuration file is called Yolo V3 Tiny in a second, but we're effectively passing a configuration file. We'll look at that in a second, okay? But from that, go on, Chris, have you got any questions there?
No, that's... Yeah, it's making more sense now how the sort of the back-end processing is coming together before it gets to Azure.
Yes, and we'll talk a bit more in a sec when we get to Stream Analytics. But the point is there, we've got, so what are the modules? And we'll take a look at these quickly. We've got this camera tagging module on there. And you might think, well, what is that camera tagging module? But if we inspect this particular configuration, we've got this host port of 3000, 2000, 3003. So, I wonder what would happen if I were to say, for example, browse over to my IP of my Jetson Nano and browse to this port 3000. I tell you what, let's not wonder, let's go and do it. So there we go. So I'm browsed to it there. I'm refreshing the screen, and I've got this module thing running that is actually, you can see it's a Microsoft developed module, and it's a camera tagging module. So basically, this will lead us into the next phase. We'll get to this in a second. We'll talk about it in a second. But what would we need to do? Why would we need that? Well, we get to it in the next phase when we talk about training one of the models. But you can see this module is actually running off our device. So this is another piece of functionality, effectively, that's running on a device. If we scroll down further and have a look at the next device, right, we've got this Azure Blob storage on IoT Edge, version 1.2. Again, that's an Azure service that it's pulling down onto the Edge device. It's actually pulling down a blob storage container. And what we can actually do is we can set these environment variables, things like local storage account name and the storage account key. You can see I got this env file here. And this env file, without really doxing the situation too much, has got a key. Yeah, it's the key that you should never share, especially not on any kind of video streams, but nobody can see the end unless they're really clever. I was
going to say there, John, there's a you
and they can be bothered. And they can do the string. But that is actually environment variables that are feeding into this template that are now, we've got a local version of a storage account, but now it has the capability to connect with a storage account that's hosted in Azure. That's interesting, isn't it? So if we flick over back to our Azure portal quickly and have a look at that storage account that I just called out. So I've got a few in here, but the bottom line is it's the camera tagging module storage account, yeah? Now, okay, so I've got the ability to, and this is touching, do you remember we circled that storage functionality? So if I were on my my image capturing module, and say I wanted to capture an image from that, and I wanted to say person, or maybe I'll just give it a completely new tag name called John. I know I've not captured anything, and I call image name 12345 add, I'm not going to add a tag, I'm going to save image. And the image has been saved successfully. So I could do that on a piecemeal basis, yeah. And I could change my camera and go to the street view, and I could see that actually now I've got this image here that's now on my camera tagging module. Right, what do I do with that? So I can upload it. So we'll get to this bit in a second, this custom vision, but I could upload it to blob storage. So I could click on blob storage, push to local storage, which would actually be pushing it to that container that we've got sat here. If I go to the right window, actually pushing it to this Azure Blob Storage on IoT Edge container. And in turn, in doing that, you can see hopefully success. That's great. So I wonder what would happen then if we look at some of these other parameters that we can set in here, which actually they're on the other manifest, so we won't dig into them here. But basically, that container that's on the local Edge device has been configured so that when it receives an image, it automatically syncs with whatever its class as its local, environment variables, which we've configured to be the key, the storage account connection string, and the key for our storage account that's hosted in Azure. So let's flick back over and let's quickly go to, there's our storage account. Let's click on containers. And let's click on my camera tagging module in the cloud. And I've got this container now. So I'm in Azure now. I'm now in Azure. I've got a folder called John, and I've got an image called 123456 that I could possibly download and possibly open up. And there we go. So you can see that built into that now, another piece of functionality. And this is hopefully showing you, if I go back to the IoT Edge, the IoT Hub, hopefully it's showing you that the modules that we've actually got on our Edge device, the Jetson Nano, we've just used the camera tagging module to take that picture. We've saved it to Azure Blob Storage on the Edge device that is then synchronized that back up to the cloud storage. But look, we could do something with it, yeah? That could further our application for whatever. Now, having spoken about that point now, have you got any questions at that stage, Chris, before we click into the next piece?
Yeah, so there's just one question when you were in VS Code, and you mentioned the parameters. Where did you gather that information for the certain parameters that you could add, or like customizations?
So what, in terms of the environment variables for the storage account or the parameters, which bit are you talking about?
Was there any documentation anywhere that that you got this
Yeah.
information from?
Right. Okay. So, when you look at a document like this, a JSON file like this, sometimes a little bit overwhelming. You think, well, hang on a minute, I wouldn't know where to start with this. How would I piece? What would be my first thing? What would I need to write? So, luckily in VS Code, we can hold Shift, Control, and P, and we can develop a new IoT Edge solution. Yeah. And if I were to, for argument's sake, now let's just set up a quick, and we'll digress slightly, but I think it's probably worthwhile just to kind of illustrate the point. If I can find a place to put it, IoT Edge test solution. So I'm going to select that folder. Let's call it back to school. Oh, as he hits Shift. We'll call it back to school, and we'll say, right, what do we want to put on there? So if we, for argument's sake, were to say, well, let's just start with an empty solution. What kind of scaffolding do we have in this JSON file? So let's start with an empty solution. It opens up in a new VS Code, but we instantly get this template document that has got all the scaffolding to kind of start to piece together. And you can see that by default, remember those two system modules, the Edge Agent and the Edge Hub? There they are. They're there. And obviously, like anything, the more digging that you do around what the capabilities are in terms of what create options can we add to this JSON file, which, look, you go off and browse some Microsoft Docs and find out and do a bit of jigging and poking. That's a good starting point. That gives you your scaffolding to start. So you think, okay, now if I wanted to get that NVIDIA DeepStream module inserted into this JSON file, I could right-click. I could say Add IoT Edge module. And I could say, right, I wonder if it's actually in the marketplace, for argument's sake. So if I can find, if I'm not going blind, there we go, module from Azure Marketplace. Let's just see if we've got access to any modules in the marketplace. So I'm hoping I'm still signed in, and it's not. Typical fashion. NVIDIA. Oh, right, okay. So I'm not signed in. I'm not going to go there. I'm not going to go there. Right, okay, we're back. We're back. So see that blip? If I can get back to it, I'll try and edit that little funny bit out there because right, we lost Wi-Fi. It was my fault. So we're back. So where were we, Chris? We were just seeing if we wanted to add another module. If we wanted to add that module from the marketplace, there we go. We got internet. So this kind of just errored, which is just before it's come back now. My Wi-Fi dropped. So if we wanted to add that NVIDIA, we could do a search in the marketplace, and that DeepStream SDK module is actually there in the Azure Marketplace. So we could just click. We could pick the version that we wanted for Jetson. That's in preview. That's no problem. We could just import that. And straight away, we get the actual relevant JSON formatted stuff that's in there. And you can see now we've even got access to our entry point of our Test 5 app. And we've even got a placeholder for the text file, this mythical text file that will take us through into understanding actually how our application is working. So does that make sense, Chris? Does that answer your question about how do we kind of pull this together?
Yeah. It's more of a case of if someone was starting with this, how do they configure it and how do they get the information to make a start, really?
Yeah, absolutely. And like I say, it will, if you're doing this for the first time, like I say, you've got Paul DiCarlo's GitHub repo that'll talk you through this. He's already got one of these manifests in place that we can use to deploy it. Equally, if you're looking to do something a little bit less intensive, remember that we can browse over, we can add modules, we can set modules here. Hopefully that'll kick back in now, but we can add a module directly to our device from the marketplace or Stream Analytics or an Edge module directly here. So we could pick, and you can browse and see all the functionality that we got in the marketplace. But remember, we're using the NVIDIA DeepStream SDK module. We've got the camera tagging module to do some funky things with capturing images, and Stream Analytics module. So we're using 4 custom modules at the moment. These 4 to do something to push data up to our Azure IoT hub. So let's move away from this slightly, I mean, in fact, no, I think what I'll do, we'll talk about this text file quickly first, I think, Chris. So in terms of this text file, which I'll just have to open up my my folder again, so bear with access to that particular. Did you follow where that went then in terms of those modules, Chris? While I open up this folder.
Yeah, no, that all made sense. Yeah, obviously, it was just like have a little look at this text document now to see where the other bits of information, shall we say?
Your mic's drifting in and out again, Chris. It is. I don't know, but I could just about hear you anyway. But no, that's cool. So anyway, browsing back over, you remember, in our manifest, we've got this text file that we pass through. At this moment in time, we're using this Yolo V3 Tiny. I'll dig into that. We'll branch off in a sec to actually looking at the development of those object detection models. But the text file we're using happens to be this one here. So you can see that's called dsconfig Yolo V3 Tiny. And look, as part of this custom app, we come with a few sample configurations that we can use to jig around. But if I were to show you this, so rather than being a C or a C++ or Python developer and building that application up from the ground up, we've got this sample application that we can just use this configuration file to configure the output and the conditions that we use for our application. So do you recall that we had those two videos, one on top of each other with me and the street? That was a tiled display, and it was enabled. We've got a 1 next to it. It was 2 rows, 2 videos, and its column is 1. You imagine if you had multiple video cameras, you could have rows of 3, columns of 4, so you could have 12 video cameras. Now, 12 wouldn't be recommended on a 2 gig Jetson Nano. I think it's just about on the edge dealing with 2 cameras at the moment. But okay, you can specify the width and the height of that window that shows them. And there's lots of different parameters that we could set for that tiled display. If we scroll down and look at these source attributes. So source 0, we're enabling it with a 1. We've got a URI type. So that URI is browsing to the, you can see my password. Don't dox me. You have to get through my network first. But that's my username and password, RTSP, on the camera, the Wi-Fi camera. So if I were to take that camera, and put that into VLC, that string, lo and behold, there are my 2 cameras. So straight away, you can see that there's no inference going on here. This is the live raw stream. You can see the time, the date, the time that it's being streamed. This is the live feed across my network at the moment. That's a live feed outside my house at the moment. These are the feeds that this config file, if I shift them off the side again, this config file is making reference to. So source 0 is referring to my street camera. And source 1 is referring, if we look there, 10.192.168.1.43, is referring to my studio camera. So look, again, there's lots of different, we've gone for URI, but you can ask what a camera V4L2, that could be a physically plugged in camera into the device that we can reference rather than over a URI across a network. There's CSI cameras. There's lots of different types of devices that we can access. We could even access, which I think may be removed out if I remember rightly, we could even access pre-canned video. So it doesn't have to be a live video feed. It could be a video that you've recorded and uploaded and then want to hook in and do some inference on. It doesn't have to be real time. You can feed MP4s or various movie formats and film formats. You can see there, we've got all of that kind of stuff. So as you go down this config section, and I'm not going to dwell on it too much, but you can see things like stream multiplexing, stream MUX, live source 1, batch size 2. What that is to do with is when these are multiplexed, these video feeds are multiplexed into that grid of 1 row or 2 rows, 1 column, what the SDK does is it actually takes inference across that entire multiplexed image. So it does the inferencing specified at whatever frame rate you want to specify. Now, if I can remember where the config is, which I can't at this stage, but there is a place that I believe I believe, don't quote me, but I believe the batch size might be the frame rate that you're actually doing. So anyway, I'm not going to dwell on it too much, so because I can't remember now as we scroll through the actual config file. But you can specify the number of frames that you actually want to take that inferencing from. And normally that's because, for me, I couldn't do it every frame because, look, the Jetson Nano 2 gig device, as much as it's a great device, it's probably pushing it a bit too far.
Mm-hmm.
So does that make sense so far?
Yeah, definitely, John. You know, I think my brain's starting to work its way a little bit here and go into overdrive. But I can really see, you know, one of your earlier slides reference like security and shopping. And I'm with you saying about stitching all the videos. All I'm picturing is like, you know, when you see like the police CCTV rooms, and obviously they've got tons of cameras all over them walls. You know, I can see real world use case scenarios for this type of stuff where obviously the people that are sitting there watching them cameras have only got one pair of eyes. You might have a couple of people working there, but effectively you could have something like this that is looking for unusual things.
No, absolutely,
and setting the alerts up. Also, another case, I've got a friend who done a sports science degree, and I know he's done a lot of sports analysis. I'm thinking, you know, being a big football fan, this is something that potentially they could use within that field and that area. You know, analysing player data, and now at the moment, I know it's all done manually. Should we say, you know, with the sports science analysts, and they'll sit there and watch that video, whereas this could take a lot of that overhead off. And maybe
without a shadow of a doubt,
and maybe be even better analysis, because obviously you've got machine learning and everything involved here that it could potentially pick up stuff that humans aren't as this is developing and learning.
Well, look, at the end of the day, Chris, this whole video of what we're going through today is really about trying to inspire other people to see actually there is an entry point here and there is a way that you can start to investigate some of these concepts. But you bang on. I think a lot of this is really down to, you know, how creative are you from an imagination perspective, and, you know, what can you do? What can you develop? So, look, Chris, let's move on to the next stage, which is really about, look, we've had a bit of a whistle-stop tour through the SDK, how that's gone together. You know, we had Wi-Fi drop at the moment, so I've just fired off back those modules running again on the edge device. I've left the camera tagging module device off for the time being, just to try and save a little bit of power on it. But if we move into the next phase, so basically, we're doing some inferencing, How do we train that model, and what does it mean to train that model? So if I flick back over to our slide deck, and let's move on. So like I said, just picking up the back of that, to get into that SDK and that DeepStream SDK and everything you can do with it, jump on over to some of the NVIDIA, sort of the Deep Learning Institute, and take a look at some of those courses, because there's some great information. And also there's some great reference material, obviously, in the how-to and the startup guides of that DeepStream SDK, where you can take a look at all of those different parameters in the config file, and you can really dig down in such a level of detail to understand specifically what conditions you might want to set one parameter over another. But look, you know, this is all part of the fun that you kind of look into. So let's move on to the next piece now. And I appreciate, you know, time's pushing on. We're doing all right. You know, this is a lot of information we're imparting here. So look, we looked at the camera tagging module. So custom vision AI, we're going to take a look at that now, Chris, in a sec. And we're going to look at how do we train our own model to detect objects of our own choosing. Yeah, you saw on that camera there that we were, you know, if I quickly, I don't know if this is back up to speed there, but there we are, we're back up and running. But you can see we've got blue boxes, white boxes, red boxes. They're detecting things like cars, person, TV monitor, keyboard. What if I didn't want to detect all of those things? Could I train, you know, my own model? And the answer, of course, is yes. So we've got a couple of different options. We're going to look through both now and look at some pros and cons and work out why we've got a certain way. But straight off the bat, we've got this thing called Custom Vision AI. We're going to dig into that in a second. That is really developing our own model based on our own set of images, hence that picture there, and I'll show you a little bit more detail, that we kind of pick and tag and train and test our imagery, and use that training data to make sure that our object detection is good for what we want it for. Or we can use a pre-trained model. So there's lots of different pre-trained models available that we can download. And, sometimes, Paul referred to them as academically trained models. So, an institution or a society or a group of people or, like-minded folk would have gone and trained, various things. Like NVIDIA have got a whole bunch of, different trained optimized object detection models like PeopleNet and face detect and face detect IR. They're all very specific. Things like license plate recognition, traffic cam net. Look, you could imagine why and when you might want to use some of those models. Yeah, when you've got a camera pointed at a road detecting ANPR and stuff like that. So we could use them. Or you've got these things called general purpose model architecture. So general purpose model, things that maybe they're trained to a certain extent. They can detect certain objects and they've been trained to a certain level, but maybe you want to take them a stage further and train them a bit more around your specific needs. So you've got these general purpose models. So does that make sense, Chris? Did you follow that? We've got our custom vision where go on. Sorry, Chris.
Yeah, no, I was just going to say, so obviously you've got the more advanced stuff, and then you've got the general purpose, which is more what we're focusing on, as, should we say, a smaller project?
Yeah, no, exactly. So what I'll do quickly is let's jump back over to the desktop now quickly, and have a quick look at Custom Vision AI for a start, just to see when might we use that. So we saw the camera tagging module, yeah? And we saw that we had the ability to kind of capture, I think I might need to refresh that. In fact, I didn't restart it, so that's not going to be online now. But we saw that earlier where we could capture an image and we could upload it to local storage on the edge device and sync that up to the storage account. We also had the option in there to sync that up directly to a Custom Vision AI project. So Custom Vision AI is a service that Microsoft has, that you can set up a project, you can sign up for it using your Azure AD credentials, log in, and you can set up a project. So I've got one. So if I sign into that project quickly here, you'll see I got a whole bunch of images here, and I got a whole bunch that have been marked untagged. And you can think, well, why have you got these images? Well, it's a case of, right, okay. Firstly, how do I get these images? So the point here is that I could have a whole bunch of images where I could say, actually, let me click on a few pages. Let me find something. Oh, there's me. There's a few pictures of the street that have been previously uploaded. And I could pick on this image because I'm in untagged here. And I could say, right, okay, I want to tag this. So you can actually use Custom Vision AI to kind of hover over various objects, and it'll automatically kind of detect this bounding area. And maybe we'll say, right, that one there, that is a car. Okay. This here, that's a car. Now, I've used that image and I've tagged it. Great. And I can move on to my next image. There we go. It's given me a very similar image because I got lots of them. Right, that's a car. That's a car. And so on and so forth. Yeah. And if I really wanted to, I could start highlighting the bins, the windows, the houses, whatever I wanted to. I could highlight this and call it a lamppost. I could highlight and tag it with anything I liked. Can you spot the obvious issue here, Chris? Go on.
No, I just had a question there. Obviously, it's highlighting the cars already. Is that because they are trained already, or
no?
Can you manually drag over an area and say this is a bird, for example?
Yeah, absolutely. So they're not trained already. The reason it's doing that is because of the cleverness, I guess, if you like, in the Custom Vision AI portal. When you upload these images, it'll automatically detect differences in the images. It has no clue what they are other than there's something different here. So I'm going to automatically put a bounding box. It's like a little helper. You want to tag something, so you're obviously going to tag this thing that looks different in the picture. So you can click on it. But equally, if it's not doing anything across that drain cover there, it's not automatically. But I could absolutely, highlight that myself and give it a tag myself if I wanted to. Yeah. But I was going to say then, Chris, can you spot the problem with this approach? Maybe is there anything?
It seems it seems quite manual process of obviously going through each picture and tagging. And also,
Bang on,
I mean,
yeah.
I've got a bit of a question. Sorry, am I jumping ahead?
No, it's all right. No. It's just I think we got a little bit of a delay. You carry on, Chris. Ask your question.
Yeah. So the question I've got, really, John, is this seems quite manual. This side of it. How many pictures would you need to train this model up? Like a minimum?
Yeah, brilliant question. I think by default with custom vision AI, you need a minimum of 15 images per tag. So, if you were to take this image and tag a car, a bin, a house, you'd need 15 images each with that tag in as a minimum.
Right.
Now, generally speaking, after testing, you can do this yourself, if you're on a call, but 15 images isn't an awful lot. It might be great. And the other thing to consider when you're doing things like, custom vision AI machine models is just remember that the placement of the camera affects the image quality. You can see my camera's mounted inside behind glass, which is great in the daytime, but when it's nighttime, I get a lot of reflection. So of course, and it's going to be dark. And as much as that car might look like a car now, because I can tell it's silver, in the dark, it won't look the same. So the point here is that it's not just a case of getting, a bunch of, the point is getting lots of images over a period of time for different atmospheric conditions, things like in rain. Obviously, you've got to be so precise for how you train these models based on the atmospheric conditions and your camera placement. Because that street light will probably switch on at night, and it actually does glare across the glass. So, do you need to capture? There's so many ways and things that, eventualities and edge cases that you kind of need to factor in when you're training your own model. Yeah.
Yeah.
And of course, the other obvious problem is, how did I get all of these images? These images are over a period. Do I need to sit with that camera tagging module every minute, clicking a button? That is a time-consuming process. Now, the way I did it, just to kind of, just to let you know, is I ended up automatically just running a bit of a bash script, using FFmpeg, and just every 15 seconds, just taking an image and storing them locally on my computer. And I just left it run for a couple of hours. So you can see, if we just quickly look at the capture script that I used, I won't run it. I don't want to run it. Open with Notepad. You can quickly see that the, actually, it's the auto capture we want to look at. So you can see that I was basically capturing my RTSP stream using that capture shell script, sleeping for 15 seconds, capturing again, sleeping for, so you can see how I did it. So I just left that run for a period of time. So I ended up with that whole bunch of files that kind of, hopefully over that period of time, the idea is that, I had a bit of a selection of images that I could kind of pick and choose from. But back to your point, You're right, Chris. It is a manual effort and it takes time. And it's not to say that it's not worth taking that time, but it's certainly time that, for me, I wanted to move a little bit quicker. So if we flick back over to our slide deck and we look at the other options that we had with these general purpose model architecture, one of the models that Paul actually went into was this Yolo V3 model, this object detection model here that I'm just highlighting. And actually, that's the detection model that I ended up using as part of this session today. So we can see that, again, I'm not going to go into it in too much detail, but the way that these models detect objects differs, between which neural network structure it's using and which type of model it is and that kind of thing. But safe to say, the Yolo object detection model that I used would detect objects and kind of overlay the grid in a grid form on a single image. You can detect multiple objects per inference, if that makes sense. Which is why you saw multiple different coloured boxes. Going back to my thing here, which is why you can see this is the Yolo V3 tiny model running on the Jetson Nano, and you can see it's detecting multiple objects in one frame. Yeah, does that make sense?
Yeah. Yeah, that makes sense. I've got a bit of a question around Yolo and it being a tiny model. Is this is it a cut down version? Is it, and they have a more advanced model, or
Yeah.
where,
Yeah, no,
which
no,
that?
absolutely correct. I think it's well picked up, and of course, with these things, then you're right, Chris. I think the Yolo V3 model. I can't even remember how many different object classifications it can actually detect, but it's quite cumbersome. It's quite large. So when you're dealing with kind of restrained devices, things like CPU and memory, they constrain to a certain limit. Sometimes it's difficult to run those larger models. So you're absolutely right. The Yolo V3 tiny model is a cut down version. Arguably, it's still quite well accurate. Because of the conditions of my camera, the atmospheric conditions, it may not be bang on, but it's good enough to get me learning. Yeah, it's good enough to get me past that hurdle. So that tiny model, I think, detects about 80 different objects. And it makes me laugh actually, because one of the objects that you'll find in the list of what it detects is a giraffe. So I'm thankful to say that I've not actually detected any giraffes, but we'll
That
get
was
on
my
to...
next question there, John. Do you often have giraffes walking around Wales?
We'll soon find out, and there's only one way to find out, Chris, and it's it's filtering that data and seeing if we've spotted any giraffes, of course. So
definitely,
hopefully, you'll see now that what we've explained there is there's a couple of different ways we can kind of use that object detection. We've looked at the custom vision AI, and as much as it's a fantastic service, and you can do that, and you can export those models, and you can absolutely use those models using the configuration files in the sample app with this deep learning. And in fact, I will be trying to do something with that at some point soon for another little side project. But for the purposes of where I got to with this, I decided to use the Yolo V3 purely because it was cool that I could kind of, come here to my... I'm just trying to look around and hold something up, but, what does it detect? So I'm holding my phone. I'm not sure what that's detecting it as, and I guess I'm going to have to be ambidextrous here and flick over to my my key and click on that to see. Look, it's actually detected that. I don't know if you saw, but it's detected it as a cell phone. Yeah.
That is impressive.
So you can see that I didn't have to train that, yeah? So I didn't have to spend the time. And hopefully you'll see that me holding my cell phone up to the camera there, you imagine, in order to train my custom vision AI, I would have had to take a minimum of 15 pictures of that and tag it 15 times. And equally, you can see there it's being held up, but my fingers are in the way, and it's got my head in the background. What about if it was over here? With the bookshelf behind, can it still detect it? I don't know. Struggling if I move it a bit closer. Oh, it's detecting. Do you know what I mean? So there's lots of things to consider. Now, to get a really accurate, it's all, hopefully that kind of illustrates your environmental conditions are kind of paramount. And for me, this project was just about understanding how this all fits together. Does that make sense, Chris? Has that kind of made it a bit clearer, hopefully?
Yeah, no, definitely. It looks like Yolo.
Okay, another glitch there, Chris. You're back now, though, with me. Yeah. So you know how much I love editing. So do you like that last little edit I did there?
It was fantastic.
It was good, wasn't it? So yeah, you're talking about the Yolo V3 tiny model. So of course, it's for those constrained devices. We got it running, detecting, sort of up to 80 different objects, and we'll look into that now. So I think we'll kick on to the next piece. So the next bit we're going to have a look at, again, I know this video, we're approaching the hour and 25-minute mark now. We're doing well, and I think we've got sort of two different areas to look at now. And the first one, from an insights perspective, is that we're going to look at this concept of stream analytics. And actually, what is stream analytics, and how can we use it, and how do we use it within this particular kind of solution? So straight away, we can see that using stream analytics, it kind of, it's one of those things that it's about ingesting that data like we've got on our IoT Edge device. We put it somewhere. In this case, it's a hub. That hub can either be the hub that's in the cloud, the IoT hub that's in the cloud, or it could be the hub agent that's actually located, on the edge device itself. And the important concept, which we'll dig into in a second, is that we've got two different types of stream analytics job. We've actually got the cloud job, and we've got both in this example, that runs in the cloud, and we've got the edge job that runs in one of those modules in the edge, on the edge device. And if you remember, one of those modules that we had was a stream analytics module. So we've got both, and we'll dig into that in a second. So the point is then, it's doing some analysis in real time of data, those messages as they go through the stream analytics job. It's taking a look at that, and it's doing some logic. It's doing something to it, and we'll look at the logic that's happening in the two jobs that we've got. But typically, it's in the format of a SQL statement that gets written, and how we write from inputs and outputs. And again, I don't think we'll dwell on it too much because of time on this video, but hopefully we'll get the high-level concept of what that's all about. And finally, again, we can use stream analytics jobs to push that out into Power BI dashboarding that we'll take a look at in a second. So the particular function that we're going to be using for our edge job is this windowing function, where do you remember we had all of that data streaming up our screen from the IoT edge, those, every time there was a detection, it was scrolling up our screen. We could basically batch all of those messages into 15-second chunks, as you can see in this kind of demonstration. So whenever those messages were sent, the last 15 seconds, take that snapshot, do some processing on all of those messages, like group them, average them, do whatever we need to do with SQL statements, and then send that message. Take that one message and send it from our edge job to the hub. So let's jump back over to the desktop, Chris, because I think, at the end of the day, that's very specifically what we are doing. So if you bear with me, let me just get the appropriate page on the screen, and we'll flick over to the desktop. So like I said, we've got two types of stream analytics job. We've got the cloud job, which you'll see we've got one here called IoT Hub, which is the cloud IoT Hub to Power BI. So we're using that to stream data out of the IoT Hub to a data set. We'll get to that in the final section. For now, we're going to look at this DeepStream stream analytics job that is of type edge. Okay. If we click on this job, and bear in mind, if we go back to our manifest, we could click here and we could add another module, and we could say we want to add a stream analytics module, and it would ask us to name it. It would ask us, we could pick the module that we've to use the stream analytics job that we've actually got set up here. Yeah.
Right.
So we can link it to this stream analytics job. So if we look at what that's actually doing, if I make my screen a little bit bigger, you can see that this concept of inputs and outputs. Yeah. So I've got one input called DeepStream input, and just remember the name of that DeepStream input, because what it refers to when we talk about the messaging, which we didn't get to earlier, we don't want to use this one. Have I still got that open here? Yes, we have. So if I click on this template and we look at the messaging, which is located generally down the bottom of our manifest. So do you recall that we've got, where are we? So we've taken, let me minimize that and go back to the web page. Apologies. So we've got this DeepStream input from the Edge Hub. So anything that comes into this DeepStream input, So where would it be coming from? It would be coming from our DeepStream DeepStream SDK module. Jump on. If I quickly log back onto our Nano and have a look. And IoT Edge list. So we've got this NVIDIA DeepStream SDK. It's failed again because we lost Wi-Fi. But if we look in the name, so DeepStream SDK to DeepStream Analytics. So we've got this route to send messages from the NVIDIA DeepStream SDK, to the DeepStream Analytics module. And what we've got is written in this notation of from anything from the DeepStream SDK is brokered into my DeepStream Analytics module looking for the input of DeepStream input. You following that, Chris?
Yeah.
So basically, this DeepStream input is taking messages from my NVIDIA DeepStream SDK. The outputs, all the outputs. So everything that comes out of that module is being sent to this DeepStream input. Yeah? You following?
Yeah.
And this DeepStream input basically is going to take the input, the messages, and it's going to do something with it. And what it's going to do is it's going to run this query over it. And this query, hopefully, you'll agree, looks very similar to SQL syntax, because it kind of is.
Looks like a KQL, is it?
Well, it's actually SQL. To all intents and purposes, it's it's very similar to KQL to a point, but it's actually SQL. And remember that tumbling window function we mentioned earlier? I'll try and pick out. So this is doing quite a lot, actually. I'm not going to dig into exactly what it's doing, but if you remember, it was taking a whole bunch of messages with the camera name, which was either street or studio, and it was detecting up to 80 different objects. Yeah, so it could detect multiple objects per inference. So what this substring is doing here, the first thing it's creating an array of all of those detections, and it's doing something funky just to tidy it up and separate them all out as separate messages. So what it then goes on to do is it's then going to count up the messages, and remember that we've got two outputs on this stream analytics job. We've got one called aggregated detections and one called summarized detections. And just think of that for a second, because we could take one stream of data and we could use one stream analytics job to branch that off to two separate outputs. Remember, this is almost to a point, this kind of publisher-subscriber kind of model, or we can route outputs from these stream analytics jobs to two other things. So maybe we want to route aggregated detections out to something else, and summarized detections, maybe we'll just send them off to a storage account somewhere. The point is, you've got a lot of functionality. So what are we doing? We're doing some tidying up basically here, and we're doing some tidying up of, there was, if it recognized an old date, it would, sometimes RTSP feeds give a default date. And so there's just some tidying up of some of the data that's going on there. So what we're doing is into aggregated detections from this initial table, which was called flattened detections. Yeah. We are where the matches are 1, filters duplicates. So that's what's happening. It's going to take any duplicates out. It's going to group by the sensor ID, the object, and the timestamp every 15 seconds. And it's going to send a message out. Yeah.
Yeah.
Do you remember in our output here, if I can remember where we had it, I'll try and get that set back up now quickly, just so that we can see it. Does that make sense, Chris? While I quickly get these up and running again, is there any questions on that?
Yeah, no, I see what you mean. Are we referring to the part where it was just spitting all that data out constantly? And
yeah, well, I mean, give it a couple of seconds now, and I'll show you again now. So hopefully it makes a little bit more sense. So we'll start our DeepStream. So this is just restarting that DeepStream Analytics container, and we're going to restart the SDK as well. So hopefully we'll get to the end of this video before it crashes us out again. So we've restarted those. We can have a quick look at, if I go to Docker logs, -f NVIDIA, hopefully.
It's quite interesting that though, John, because there's obviously, you can see where that's going, that you're filtering the information maybe slightly differently. So you could have different use cases for it from the same information.
Precisely. And you can see how powerful this can get now. Yeah. So this opened my eyes up to the stream analytics jobs, the capabilities that we're effectively taking this stream of data, all of this data here. Remember, this is going to the edge job. This is running to that module that we just restarted on our edge device. So everything that's coming out of our DeepStream Analytics SDK, which is everything that's coming out of this module, that all the logs are flying up, which is our NVIDIA DeepStream SDK module, all of these messages are coming out of here, and they're being sent into, they're being sent into our DeepStream Analytics module. Yeah, do you remember we just saw that? Yeah, on the paths here. So they're being sent from DeepStream SDK to DeepStream Analytics. And this DeepStream Analytics job is doing something to the data. It's basically sorting it and filtering out duplicates. It's doing that transform of the data. So you've heard this kind of this transform load kind of function. So it's transforming that data, tidying it up, aggregating those detections, and then it's sending it to this output, which is aggregated detections. So if we look at that, and it's using this tumbling window of 15 seconds. So now we've got that restarted. If we go back over to Visual Studio Code and we right click on our edge device down here in the bottom and then turn back that built-in monitoring. Do you remember we saw this earlier on where every 15 seconds we're seeing this message arrive to the IoT hub in Azure. So this is the message that's actually arriving, and that is the function, the Stream Analytics job that's actually doing that. Yeah. So, and just to confirm that, not to labour the point too much, but that every 15 seconds, if we look at, so we've now got another route here from DeepStream Analytics to IoT Hub. We're seeing that anything from, well, actually, it's a summarized detection. So we talked about the aggregated detections, but actually these are being streamed from this function here. So into summarized detections. So what this is doing is it's a smoothing function. Basically, because of the flickering nature of those bounding boxes, sometimes it can detect one thing, but it can count as two because it's kind of going on and off because of the fact that I put it for every 4 frames. So this kind of tries to act as a bit of a smoothing function over that time. You know, if it's detected 1, then 2, then 1, the averages are it's probably only detected 1. So this is what this function, and you're gone. And you're back again, Chris.
I'm like a jack in a box, aren't I?
Well, no, it's me. It is. I think I'm losing connectivity now and again, but it's great. You know, it's great to see how quick I can pause and reenact this video. So, anyway, does that make sense, Chris, in terms of this Stream Analytics job and what we've got? So remember, this is the edge job that we're running here.
Yeah.
Does that all kind of make a little bit of sense?
Yeah. As I say, it's nice that you can see that the outputs you can use them for different use case scenarios. So in my head, I'm thinking of this as a real world scenarios, where obviously stuff like this, once it's scaled, that is where it's used, and I see the benefit of you only need one bit of information going in, but then it can go off to other teams or whatever.
Remember that map of things that we had. We got event grids, we got storage accounts, we got all sorts of things in Azure we could be sending it off to. So that's the point, is that it's so powerful. And remember, we've also got this other job, this IoT Hub job that's a cloud job. Now, if we look at this in comparison, and we won't dwell on this too much longer, but you can see all this is doing, it's got a single input and a single output. All we're doing is taking everything from the IoT Hub, and we're sending it straight out somewhere else. And we're going to use this Stream Analytics cloud output actually for Power BI to hook into a data set and take all of those messages into a data set. That makes sense.
Yeah, no, definitely. So event, you could have a nice fancy little report of what you've seen, or I'm looking at this once again from a real world case scenario, obviously, where you've got things like traffic surveys or anything like that, where all that information, you just put wire across the road and like a little sensor box. Effectively, they just need a camera. And even video, where they could potentially just get that from maybe the council's CCTV rooms, if that's already cameras up, get that information, and then they can complete that traffic survey through this, rather than having to go out, visit sites, set up equipment. There is other ways now where they can integrate with different services to get the same outcome, which should improve things for everyone.
Yeah. That's exactly it, Chris. To be honest, I think it's down to people's imagination of how to use it. But Anyway, I mean, that was stream analytics, so we wanted to touch on that. We covered so much off, Chris, and I was conscious this video was going to be quite long, and we are. I think we're going to push the 2-hour mark, which will be a great video. I'd love to, I think we'll have to give a prize. I'll have to give a Welsh Azure user group T-shirt out to the person that can watch to the end. No way of managing that, so don't be so silly. So okay, let's move on, Chris. Let's move on. In the interest of time, we will flick back over to our slide deck and have a quick look at the next piece. So now we've done all that fantastic stuff. We've seen what that application looks like, running those inferences across that video analytics. We've done some stream analytics and pushed data up into our IoT hub, and we've seen it come through every 15 seconds into our IoT hub. So, what can we do with that? How can we visualize that data? How can we get those insights out of that data? So the last two quick sections, and we'll make them quick for the interest of time now, Chris, is really about what kind of tools can we use to start doing something with that data. So the first thing we're going to look at is time series insights, which again is a service within Azure that we can use, we can set up, and we can use to actually start looking at some of this data, in kind of real time. And because the data, if I at this stage now, I mean, I can quickly flick over. I won't flick over just yet. We'll get to the point, but I could flick over and we could look at the time series insights for the object detection piece that we just talked through. And look, let's face it, it's not going to be very fun. It's not going to be very visual because there's not a lot of data really. It's just one person that is detecting sat in an office. Well, I'll show you it, but you'll see. So what I've got set up is another little device. It's sat down by the side of me. It's a little MX chip. It's a temperature and humidity sensor, the thing of IoT dreams. But, I've had this set up and it turns on every morning when I turn the computer on, and I've got that sending data up into a time series insights module effectively. So what I'll do is I will jump over to my desktop. We'll head over to my JC Temp time series insights environment. And, at the end of the day, we can click on overview. We get this link to the time series. We can see things like, how many messages have been received over a period of time, the number of bytes, yada, yada, yada. There's lots of good information that we can kind of get out of that. But the important thing is we get this URL that we can hook into. So we click on that time series insights URL. What it is an environment that we can quickly analyze timestamp data and actually hopefully make sense of it. And, like I say, as luck would have it now, I mean, I've had this running all day today and it's actually quite warm. So you can see over time at the top level, we got the ability to drag this little slider and highlight over a period of time. So you can see where it's flat is basically where I've had it switched off. Yeah. So we've got some data. Let's look at now. This is the last day. If we click over here and kind of select, what have we got? We won't do ambient. Yeah, okay. We'll do ambient humidity, ambient temperature, add. Actually, no, we can't do ambient because there's no data on there. So we'll do machine temperature. And actually, will it select? Beg your pardon. Maybe if we do those ones. There we go. That's better. So we'll remove ambient and that one. And you can see we can put them into lanes, and we can color code them up. And we can make that one blue. And we can make this one red. So we got humidity as red. So we can see certainly over the time we've recorded, Chris, humidity has gone up because I've started to get a bit of a sweat on in here now. But you can start to see, quickly visualize some of that data that's just been streamed. So this timestamp data has been streamed from my MX chip as temperature and humidity over a period of time. Like I say, it gets turned on, a lot of the time. You can see, you can go back in history for as long as, I think, as long as you've got the data in there. So this is, hopefully you'll see that that's quite a nice, quick and easy way to glean insights from data that you got stored in, in an IoT hub or coming out into a storage account, whatever it may be. Any questions on that one, Chris?
No, not a question as such, but I suppose these are sort of, I'm thinking like, your Nest hubs and your temperature sensors that you'll have around the house, all the smart home technology this is what's happening in real time in people's homes. So if, for example, something's monitoring the temperature, that temperature drops below a certain amount, and then that kicks the heating in to try and keep it all constant. So this is, I'm trying to think, we keep coming back to real world scenarios, but a lot of people might, resonate with this. They might have them devices within their home, and that's where the heating comes on and bits and pieces. Them devices are alive in our lives and constantly monitored.
You're absolutely right. I mean, they're exactly the same sensors at the end of the day, and all we're doing is we're taking the messages that are sent from the sensor and being stored into IoT Hub, and we're basically reading them. We're using this thing called time series insights to kind of try and put a bit of visualization. So I mentioned I was using this temperature and humidity because there's fluctuation, because there's variance in temperature and humidity. You can actually see and visualize a difference. Now, if I were to flick back over and go to my, let me see, time series insights. And if I were to go to my accelerated edge, which is the Jetson Nano project, and I were to browse to that environment, what you'll see is that I've been able to put, basically a couple of different filters in terms of what I'm actually looking at. And I can see my studio. I've got the street camera, and I'm in the street. I want to see how many vehicles, and I want to add that. And in the studio, I want to see how many people are in that, and I want to add that. And the point is, we'll ignore that message for the time being, but we've got some data, but hopefully you'll agree it's probably, wait for it to wake up a little bit. I've just zoomed in on it. You can see now, this is over the last couple of hours, but you can see that in the street, it's detected 2 vehicles fairly constantly. It went down from 1, it sprung up to 2, up to 3, and it's gone up and down, as I'm assuming as cars have driven in and out the street. And you can see that in the studio, pretty much since we started recording, it's detected 1 person, and it shot up, for some reason, it detected 2 people. So do you remember you remember that smoothing function, and you remember that this is the point now to kind of analyze the data. And this is where your data scientists come into play with understanding the data and manipulating it. But that's an anomaly, effectively. But more often than not, and you could start to see now, wouldn't it be great if people in studio was at 0 because I wasn't here? You imagine if I had an alert of when that went up to 1, I had it send me an instant message. There's somebody in your studio. And it's been captured from that camera. Arguably, okay, my computer, actually, the Jetson Nano would have to be running, for that to happen, of course, to do that inference. But you can start to see now that at the minute, I'm just capturing cars and people, and I've just listed them in this time series insight. So does that make sense, Chris? I wanted to call this out quickly before we move into the final piece of today's session, which was taking that visualization further. Have you got any points around that?
No, I think that's fantastic, to be honest, John, to have that analysis at hand, really. And I think it goes back to the real world scenario that I thought of before of a traffic survey. Effectively, that's what you've done. From the Jetson Nano.
No, absolutely, Chris. So, if we flick back over now to the slide deck, we're into the closing throes of this discussion, and hopefully you'll agree that there's certainly a lot to take in, but we are into the closing throes. So there is one final thing that we can kind of hook into, and we will do it again. We'll do it very briefly for the purposes of time, but just to give that final kind of close out and closure as to what we can do. So visualize an object detection with Power BI. So in action. So in other words, what can we do? We can actually take the data that we've had in, go through Stream Analytics into our IoT hubs. And if you remember, we had that other output that we'd set up from the Cloud Stream Analytics job that was basically going straight into a Power BI data set. So that's what we're going to look at. So the last couple of minutes, Chris, we're going to flick back over to the desktop, and we're going to take a look at, something typical related to this particular project. But in Power BI, we can all log in, and if you've got relevant licenses, we can start to use Power BI. And in this instance, we've created a workspace called Intelligent Video Analytics. again, if you recall back to the GitHub repo that Paul DiCarlo had set up, you can follow along with this and look at how this got set up specifically. But do you recall that we had that Cloud Stream Analytics job that had that output that was basically taking everything from IoT Hub and sending it straight into this data set, okay?
Yeah.
So we created this data set in Power BI, and we're basically using this Power BI data set to then compose a Power BI report. So you'll see now that over a period of time, we've got things. So ignore the blank space and the camera 0. Basically, that was my faux pas when I originally set it up. I didn't tag the cameras appropriately. So, of course, they were coming through from my Jetson Nano as camera 0 and blank or null. So the point being now, we can take a look and start to visualize some of this data. And to be honest, in this report, it's a little bit mishmash because I'm using that Yolo V3. So do you remember you asked, did we have any giraffes in South Wales? Well, this should be able to tell us. The answer is no. But concerningly, we did have a knife, a fire hydrant, a skateboard, a sofa, a stop sign, a suitcase, and a teddy bear. So at some stage, that Yolo V3 tiny model has detected all of these objects, and it's now being able to be visualized in Power BI and all of the functionality that Power BI gives us, like the ability to kind of write when was that sofa detected? Apparently, it detected it at 5:21 today. Okay,
wow,
fair enough. What about detections in the street? What have we got there? A boat apparently was detected in the street.
You had any heavy rain, John?
Well, this is, what I was saying about the accuracy of this Yolo V3 model. And remember, it was just for me to get set up for the learning. And no, it hasn't been raining today. But hopefully, Chris, you can start to see now. We could click on car, and hopefully that'll give us a reasonable sort of level that, it's kind of given us a count of things that it's spotted. And we can take this a stage further. So once we've done a report like this, we can kind of take it back to our workplace and set up a dashboard. And we can start to, embed our Power BI report into our dashboard. And that's all interactive. We can start to click around and change the date range and things like that. And then we can actually start looking in real time at, sensor ID. So this should update in real time. The number of, what's this telling us now? The number of people in the street apparently is 1. And the number of people in the studio apparently is 1. Obviously, because the Jetson Nano is given up the votes, we won't verify that for the time being. We'll take that as gospel. And it's telling me at the minute there's a maximum of 4 cars in the street, which is reasonably there or thereabouts because, like I say, that model hasn't been tested because of the location I got the camera, the atmospheric conditions. But, things like you can look down here, you start to pin these kind of detections and these reports. You can start to see how we can actually visualize and start making more sense of this data. So, Chris, I'm not going to dwell on the Power BI stuff in too much detail, other than to say, if you get into visualizing the data, you can start to do some really clever and funky things. I mean, any questions on this point for now?
No, I think that's absolutely fantastic. That that you can just import it straight into Power BI and get that visual, the visual look of it as well. And once again, referring to real use case scenarios, them reports, they're ready made with the information. And I know you mentioned also a couple of anomalies. But I can only see this getting better and improving the more information that Azure is ingesting over time, that all these models will get more and more accurate.
Well, it's down to us at the end of the day. And remember that it's down to us in terms of, look, I've got my camera facing me in the studio and one facing the street. There's nothing to say that I couldn't have my camera, facing, a shopping aisle and counting the number of objects on a shelf. The application is really, it's going to be as accurate as the amount of time and effort I want to put into doing it. And in this occasion, if you remember, I didn't have the time or energy to sit down and train my model to the nth degree. So I just opted to use a general purpose model that would give me roughly some kind of readings, but there's certainly room for improvement. And remember that if you were doing this in production, you probably would be spending that time and effort properly training the model, so you've got that 99% accuracy kind of, or that kind of really high probability level.
Yeah,
to be honest, Chris, on that note, we kind of have come to the end of our little journey. I mean, how have you found it, Chris? I mean, firstly, nice one for sticking round, but how have you found it? I mean, have you got anything from this the last 2 hours?
Look, genuinely, John, I think it's been absolutely fantastic. It's something that I've considered, delving into. Possibly not with camera detection, but maybe something that I include. One of my little hobbies is gardening. I love gardening, and the way you can get all these sensors and that you can implement, and hopefully look at something like this over time. When I'm growing fruit and veg, and have the sensors of when do they need watering, and just getting that analysis overall. It's definitely, I've got things in my mind now where my mind's in a little bit of overdrive, and I'm coming up. I can see so many use cases for stuff like this. And potentially I could implement a camera into a scenario like that where it's monitoring the stuff, and if the flowers are starting to wilt or anything like that, or what's growing, it alerts me. I'm sure it can. That there's. Yeah, my mind is just a bit mind blowing. Really, my take from it is, this is not the future. This is the now. The future is really here now, and I can only see this stuff improving and growing, and the level of detail is just going to keep on increasing.
100%, matey. And I think, you hit the nail on the head. That's exactly how I felt when I started doing this and kind of spent those hours working through and setting up and configuring these things for myself. It's like all of a sudden you're kind of off, I could do this, I could do that. And yeah, I mean, if you're anything like me, you struggle then for time. You need that 8th day in the week to kind of do it. But I mean, the whole point of this, Chris, I mean, like I say, huge thanks for coming on and doing this with me, this back to school event. And obviously it's a fantastic event that's going on throughout September. But hopefully, for those that have managed to stick around the whole 2 hours, brilliant, well done. But hopefully it's kind of inspired other people to, don't get me wrong, we've not dug down too deep into certain areas, and there's certainly lots of learning to do. But just to reiterate, go back and look at Paul DiCarlo's GitHub session. So scroll back to the front, check out that URL, and follow through with it. Take a little look at it, have a little play. And like you say, Chris, it'll invoke lots of different thoughts and feelings about doing other things. So, I mean, that's it. We've reached the end, Chris. I mean, in fairness, I thought we'd be good to get an hour video, and we've managed to get to 2 hours. How do you feel about that, buddy?
Yeah, no, to be honest with you, John, it doesn't feel that long at all. I'm quite surprised that it, it's rolled that long. But there's a lot of information to take in there. But then there's, and you say that's the end, but really, in my eyes, it's the beginning. Projects now that I've got in my head, and I'm like, I want to do this. I just want to get stuck in and being able to play with it, with all this when someone does invent that 8th day of the week. Exactly.
Yeah,
but I just hope that people who are watching it at home as well have got out of it what I've got out of it, because just massive thank you, John, for for letting me come on here and sort of buddy up with you and what you taught me today. It's been very, very insightful. And something that now I'll play with, and I'm sure I'll be bugging you.
No, not a problem at all, Chris. I mean, to be honest, hopefully give it a little bit of time now, and maybe we'll do a few more of these sessions as we go. See how much of the bug you get, because it's once you get it, it's difficult to shake off, is what I found. So it's brilliant. It's brilliant fun, and there's some awesome people out in the community. They all know who they are when it comes to IoT, and certainly AIoT and video analytics. Reach out to me or Chris. If you're watching this now, happy to answer any questions. We'll call it there, shall we, Chris? We'll go and have some tea now, and say thank you to the guys and gals that organised the back to school event, and good luck and enjoy the rest of the event, everybody. But I'll say goodbye from me.
And that's a goodbye from me.
There we are. It's like the two Ronnies, eh? Cheers, Chris. Catch you soon, buddy.
Oh, brilliant. Cheers, John. Take care.